All right, hey everybody, Mr. Fortin here. Got another graphic organizer for you. Now, I wasn't planning on making this, but I got some nice feedback. Thank you for your notes about the last graphic organizer about angle relationships. If the vertex is on the circle, we use one formula. If it's outside the circle, we use a different one. That's the one where you subtract the arc lengths and you divide by 2. If the vertex is inside the circle, you add the 2 intercepted arc lengths, and then you divide by 2. You average them. And what was the last one? Oh, if we're at the center, the vertex is at the center of the circle, it's just equal to the measure of the arc lengths. The central angle is equal to the measure of the angle of the arc. So anyways, hopefully you're practicing those. Hopefully you're maybe making some note cards out of those, because you want to get quick at those, right? You want to get fast, you want to get confident on them so you can move to the next thing. It's all about kind of simplifying down what you have and being able to kind of memorize what can make you faster in some places here. So those 4 things in the last graphic organizer, hopefully you got them down. Hopefully you got them memorized. Hopefully you feel pretty confident about them. If not, let's practice, practice, practice. The point of this video right here is now I'm going to go through distance, okay? Points, circles, they have this distance relationship. It's just kind of neat. We're actually going to see an application of this in Wednesday's class about how we can apply this to the real world, actually, in order to solve some problems here. So anyways, we're going to look at the power theorems here, right? The power of a point Q over a circle. And the reason why you're watching this video, perhaps, is because you were a little overwhelmed, maybe, by the last lesson, lesson 7.7. So perhaps it's Wednesday, and your problem set is to do these problems. So maybe you're watching this video because it's just like, oh, what am I going to do? I could try to guess through some things, but maybe you just need a quick refresher on what to look for in these problems. That's why I'm filming this video, and that's why this graphic organizer exists. Okay, so let me go through it real quick here. Here, you're going to have situations, really just 3 possible situations in this one. Okay, going to look like this here, going to look like this here, which is a secant and a tangent. This is 2 chords. Or it's going to be 2 tangent segments here. Just those 3 situations. That's what we'll go through right now. All right, check it out here. What are you doing? Okay, so you want to give your graphic organizer, you can fall back onto it as you're doing problems. You can look at it here. What am I doing if I got a 2 chords, right? 2 chord situation that's going through a common point here. Well, I know I have this consistent product, right? The product of this segment here, I'm going to mark it A, times its collinear segment that connects to the circle here, B, would be the power of point Q, okay? So through a point, the big thing I want to get this stress in this video, is if I didn't stress enough in the lesson, is that through a point, there's generally 2 ways that we're gonna hit a circle if we draw a line, right? So picture of the line's not there. I just have this point right here. I draw in a line, just like this. How many times am I hitting the circle? Okay, I got this point right here. I draw on a line. How many times I hit the circle? I'm hitting it twice. Once here, right, with this little segment here. Once here with this little segment of this whole line, right? So these 2 collinear segments that go point to circle times by point to circle, that's the power of the point, and it goes in your little formula because we have a power of point A times B here, and that's going to equal any other way we introduce a line through that point Q, okay? And in the problem, it's given to you. They've already drawn in the lines here, but it didn't matter where they drew in the lines. The product is going to be the same in terms of point to circle and point to circle along this line, or along this line here. So let's go ahead and fill in the rest of the formula here. Let's call that segment length C and segment length D right here, okay? AB, A times B, right? It's just, it presents itself as AB, but mathematically, if I have 2 variables next to each other, it's A times B, is going to equal C times by D, and that was the 2 chords power theorem, okay? Right? We're inside the circle. It doesn't really matter if it's inside or outside. If we have a point with respect to a circle that it's coplanar with, right here, like if the circle's not, like the point's not here, and then the plane, it's not like off a plane like here. It's on the same plane as the point, okay? So the circle's in the middle here, go boop, boop. Okay, multiply the 2 segments together, go boop, and then boop. Multiply 2 segments lengths together, you get the same product here, okay? That's what to look out for. I would, if you really want to improve your notes, I would definitely have something like this labeled up so that you know you're just going from point to circle times by point to circle. That product is the same regardless of whatever line you draw in here. If I had another line like this, okay, which I wouldn't recommend putting this on your graphic organizer because then it's just not that helpful to you. Here, this looks like a shorter length, okay, shorter length to point Q. Okay, let's mark it E. Okay, but this is like definitely the longest segment here, right? E times by F would also be the same product here, okay? Because that's the power of that point over the circle is whatever that product is here, okay? So if we're solving problems, if B is 8 and A is 2, these would actually, it wouldn't necessarily be a ratio type thing here, but 2 times by 8, maybe it would be. This is 2 times by 8, yeah, it wouldn't be a ratio, exactly. 2 times 8, the power is 16. So perhaps that's 4 times 4. Perhaps that's it. That's 4 times 4. If this is 4, you're going to know that's 4. There's the power of 16 here. All right, anyways, bunch of writing here, just kind of summing things up. Remember, you generally intersect the circle twice, okay? If you, right, the kind of key to this is that if you have a point in a circle that they're coplanar, it's all coplanar here, if you draw in a line, right, if I draw in a line here through that point and it's going to hit the circle twice. Okay, so what I'm going to do is I would take, it's going to intersect the circle twice. So just remember, the product of the length of the two segments connecting the point to the circle is always the same. Okay, always the same. Point to circle times by point to circle in that same line. Got that? All right, practice it. You'll get it here. And this is actually going to be true for our other power theorem here regarding two secants. We did two chords a second ago. Now we have the two secants power theorem. This is the same exact thing. So here we have some examples. If the point you're concerned with is outside the circle, and there's definitely going to be some applications of this one here. We're going to do in class tomorrow. But anyways, the tomorrow meeting Wednesday. I'm filming this on Tuesday. Okay, so the thing is here, it's the same deal. Keep this principle in mind when you do problems like this, because you can commonly make mistakes on this one if you don't follow this one exactly. Here, this is what it is. Remember, if I'm a point here and I draw in a line, okay, that does intersect the circle, I'm generally going to hit it in 2 points, unless it's tangent, okay, or unless it doesn't hit the circle at all, okay? If it intersects the circle, it's probably going to intersect at 2 points. So we'd have a secant segment right here, okay? If I'm going through this point and I draw in this line right here, okay, I have 2 ways I have gone to the circle. And here, the product of those 2 ways is the power of the point. So I need to concern myself with this way that I get to the circle. There's my A right here, okay? And there's another way. It's not this. This isn't going from point to circle. This is just a chord. This is connecting 2 points of the circle here. So when you're doing this, you're not thinking about the chord. Here, I wrote this incorrectly on this one. Sorry, you notice the typo here. Secant tangent power theorem. I'll update that on the master slide in post-production. So we have here A times by what? Well, we got to go point to circle all the way. All the way. So if this is not in your notes from Tuesday's lesson, you're writing it down now. You're putting it down. You have this here to help you solve problems, okay? Power of the point here is A times by B. And that's going to be the same if we go to different ways that we can draw from the point to the circle, because there's an infinitely amount of ways. There's infinitely many ways we can draw from that point to the circle. Infinitely many kind of secants that we can draw here. But those secant segments, the product of the two, the external segment and the whole secant segment here is always going to be the same. Always going to be the same here. So if it's always going to be the same, right? It's the same means it equals mathematically, right? That's what it means here. I can get to the circle, again, 2 ways. If I draw this secant segment in here, we got our external length, external segment of the secant segment, and that's C. And then I have, again, from point. So not here, right? That's the mistake a lot of people are going to be making. So you don't care about the chord here. You care about the power of that point to circle. So I have C times by D. That's it here. C times by D. All right, and there it is here. I would definitely put that down in your notes here because you're going to make mistakes potentially on this one here. Look, this isn't X times by 4 equals 5 times by 3. Why is it not? Because that's not the power of the point. The power of the point here isn't 5 times by 3. Look, this is just a chord right here. It's 5 times by what? Times by 8. 5 times 8, so 40 is the power of the point here. And 4 times by 4 plus x is another way we can express the power of the point here. And then you can solve the rest there, okay? All right, so we have that one. Then this one here is another. This is a secant tangent power theorem because the power of this point can be found not just if we intersect the circle twice, but also we sort of looked at this inductively in Tuesday lessons if we intersect the circle just once. So if I'm going from this point to the circle and I'm hitting it twice, that's one way I can calculate the power of that point. We're not going to see an application of this in Wednesday's class. We got here, this is A, and then power point to circle. Again, it's the whole thing. It's the whole thing here. So I'm going A times by, this whole distance here is B. A times by B equals, well, what if we only hit the circle once? Here, right? If I draw on this line, look at this here. I actually was very precise doing this here. Look, there's my tangent. There's my tangent line. So if I draw on a tangent line right there, I'm only gonna hit the circle once, and I'm gonna concern myself with the length of the tangent segment here, okay? So this is my tangent segment. And what am I gonna mark it? I'm gonna mark it up as length C, okay? Length C right here. There we go. So if I'm going to the circle and I'm hitting it twice, look, this is pretty little here, multiplied by a larger value. C here, what is it compared to A and B? Well, it's in between. It turns out it's actually the geometric mean. The geometric mean, yes, from chapter 6, geometric mean, we actually have kind of an average type value of the two here. Okay, it's a geometric mean. If I take the square root of both sides, I get C equals square root of A over A times B. And square root of A times B, that's actually a formula. Remember, for finding a geometric mean, it's one of them, okay? We can prove this here. If we divided both sides by C and divided both sides by B, we would have A over C equals C over B. A over C equals C over B, right? Your C's are in the mean position. C is the geometric mean of A and B. Anyways, but we can also figure out the power that way here, just by squaring the tangent segment. Okay, that's it here for my little video to help you, hopefully, on these introductory type problems here. Again, we usually intersect the circle twice. If we intersect the circle twice, you gotta remember, it's the product of the length of the two segments connecting the point and the circle, not the two segments that you think of, one connecting point to the circle and the other one just connecting 2 points of the circle. No. You don't care about that. You care about the length of point to circle times by point to circle, or point to circle squared if that line is only going to intersect once because it's a tangent. So we have tangent segment there, okay? So here, use this one for if your segments, if your lines are intersecting it twice, point to circle times point to circle. If your line intersects it once because it's a tangent right here, just square it. And that's the product here. That's the power of the point, okay? So, quick refresher, can you tackle these? I think you can here. 5 times 8, 40. 4 times what is 40? 10. Boom, we're good to go. This one here, ooh, what's the power? The power is going to be, well, yeah, this actually is a secant. That's definitely, look here, it goes a little bit inside here. The power is 5x, okay? Is 5x equal to 21? No, it's not. No, it's not, because it's 3 times by 10. Point to circle times point to circle. 3 plus 7 is 10, right? That's that other distance as we go from that point to the circle, okay? So we get 10, 30, x is 6 now. Anyways, knock these ones out here. It gets a little bit more hairy on this one, but I think if you paid attention to the proof on the lesson on Tuesday and you're good at similarity and all that good stuff here, look, you're just proving AA right here, right? You're going to get there for this one, proving the secant tangent power theorem right here, okay? I forget if I gave you one of these proofs. I might film a video on this, a separate video on this one to help you with some of this quadratic stuff, because I've noticed that's a little iffy this year. We need to figure out a way to get caught up on that, okay? And then after that, ooh, this is a very challenging problem here, number 21. So good luck on that. All right, best of luck on your homework tonight. Thank you, guys. Bye. Let me know if you have any questions.